Greetings, everyone. This is Mr. Dupes coming at you from the DupesMtStHelens Satellite Studios, and today we are going to talk about stratovolcanoes, also known as composite volcanoes. The link below gives the backstory of Mount St. Helens and when it erupted on May 18th, 1980. And Mount St. Helens is a member of what's called the Cascade Volcanic Mountain Range. And there's a reason that the Cascade Mountain Range is volcanic. So the Cascades cover the state of Oregon, also the state of Washington, where Mount St. Helens is. And actually the reason why the Cascade Range is volcanic is pretty much the same reason why the Andes Mountains in South America are volcanic. Now, we talked a little bit, I'm going to move down here a little bit. We talked about during plate tectonics how the Andes Mountains here are volcanic. And the reason that they are volcanic is that we have the Nazca Plate right here. I know there's an arrow pointing, west here, but that's for the South American plate. But the Nazca Plate right here is moving east because of the divergent plate boundary right here that separates the Pacific Plate and the Nazca Plate. So the Nazca Plate is moving east, and the South American Plate is moving west. And we said that when an oceanic plate, like the Nazca Plate, is colliding and converging with the South American Plate moving west right here, it's going to cause the oceanic plate to sink and then subduct underneath the less dense continental plate. And the very edge of the oceanic plates underneath the Earth's crust forms magma chambers, which makes the Andes Mountains here volcanic. Well, sort of the same thing is happening with the Cascade Range right here because of what's called the Juan de Fuca Plate. Okay? The Juan de Fuca Plate is a very, very small oceanic plate. And it comes from actually this divergent plate boundary right here. And on the west side of this divergent plate boundary, you have the Pacific Plate. And just to the east of it, you have the Juan de Fuca Plate. Now, since this is a divergent plate boundary, the ocean floor to the right of it is going to move east, move to the right. And as it's moving east, it's going to collide with the Pacific Northwest states of Washington and Oregon. And this is what makes mountains like Mount Hood in Oregon, Mount Rainier in Washington, and our featured volcanic mountain, Mount St. Helens. This is what makes those mountains and the Cascade Range volcanic. Okay? So this is actually a subduction zone. And wherever we said there was subduction around the world, when an oceanic plate is colliding with a continental plate, there is going to be volcanism. And there's volcanism coming from the Cascade Range right here. Okay? So I wanted to explain to you, the formation of the Cascade Range and also what makes the Cascade Range volcanic. And that happens to be the answer right there, is that the Juan de Fuca Plate is moving east and subducting under the states of Oregon and Washington, causing the Cascade Range to be volcanic mountains. Okay, so Mount St. Helens, Mount Rainier, Mount Hood, they are also members of the Pacific Ring of Fire, and that pretty much spans the entire Pacific Plate because the entire Pacific Plate is surrounded by land, okay? And the plate is subducting under the land, which makes Eastern Russia, Japan, New Guinea, the west coast of South America all volcanic, and so on and so forth, okay? So go ahead and click the link below, and it gives you the backstory of Mount St. Helens and the day that it erupted on May 18th, 1980. This is Mr. Dupes coming at you from the DupesMtStHelens Satellite Studios, saying so long, Raider Nation. I am out.